Hello and welcome to another video. In this one, I'm going to show you how I trained a custom object detection model for images. I know, very, very unlike my content, but I did it. So I wanted to show you the process as well as every stumbling block I hit along the way because it was far from a smooth process. But anyway, let's jump into it. Okay, so kind of the goal of this is I was playing Pokemon and I wanted to automatically detect Porygon, Porygon 2, and Porygon Z in a video feed, essentially. And this is kind of the result of what I got. And at the same time, I wanted to be able to detect all of these and not detect shiny ones. The goal to be to find a shiny Porygon, or particularly to find a shiny Porygon Z. But and so I trained a custom model, and spoilers, I didn't end up using it, but we'll talk about that later. And I wanted to show you the entire process for doing this. We're going to be using two pieces of technology. One is Label Studio. This is going to allow us to annotate our images and give our model training some data such that it can spit out a model that we can then use to identify particular Pokemon. And then we're going to be using yolov8, also known as Ultralytics, which silly name, don't know why, but sure, there we go. But that's what we're going to be using. I have prepared a few images beforehand that are unannotated. We're not going to actually do the full process, but this should give you an idea of like some of the input that I'm giving to this. I made sure to include data that is of all the classes I care about. So some of Porygon, some of the shiny, Porygon 2, and I think there's a few Porygon Z's in here. This is nowhere near enough data to annotate. When I made my actual model, I started by annotating 300 images, and it was very inaccurate. Only after annotating about 1,000 images did it do decently well, and even then, I probably should have annotated more. But by the time I annotated 1,000 images, I had gotten it with my crappy algorithm that didn't involve an object detection model. All right, anyway, so step one, collect all of your images. I fortunately had the forethought to take screenshots while my automation was running, so I had a whole bunch of screenshots to go with. Next, we're going to run Label Studio. They have a corporate product that you can pay for. They also let you run it locally with Docker if you want to just try it out. That's what we're going to do today. I've already run this command, so we're going to run this command, and we'll find this command is actually broken. So let's start by pasting this, and before we run this, Docker commands should almost always be run with RM, so we're going to do that so it doesn't pollute our setup here, but let's start with this. And it immediately says no directory my data. This is because I'm actually running Podman, and Podman refuses to just make random directories on your system, whereas Docker totally will. So let's set up that directory. Next, we'll run this, and we get a permission error. And this took me a long time to figure out. A few other people had run into this without a good answer to it, but it turns out it is because I'm running rootless Docker. So I actually need to elevate my user to root. And by elevate, it's not actually an elevation because it's rootless, so it's just so the permissions work out properly. So if we do this, this should allow us to start our server. It takes a little while to get started. It's a Django app, and so it sets up a database from scratch and runs completely locally. And so once this will be set up, we should be able to access it in the browser at localhost 8080. And it is not ready yet, and so it'll give you a connection reset until it starts. It'll also print a little message when it starts as well. It looks like it should be started now. Cool, and that presents you with this login screen. This actually confused me a lot because I was like, I don't have a login for this. Do I have to like sign up somewhere? It turns out that this is entirely locally, so you can sign up with whatever garbage you want. I would recommend using something like example@example.com. That way, even if it does happen to use a generated password. No, we're gonna use bad password. Use example.com. That way, even if it does try and send email in some crazy way, it's not gonna go anywhere. I don't care about getting news from whatever this possum? Opossum? I don't know the difference. Anyway, create account, and that's gonna get you started with Label Studio. From there, you want to create a project, which is straightforward. I'm gonna call mine Porygons. And don't really care about description. I'm the only person that's going to be working on this. Workspace, don't have one of those, and clicking this does nothing. Cool. Data import. We'll actually get to this later. I recommend creating your project first and then importing data later, just because the data import is a little sketch. Let's go to labeling setup. We are going to be doing object detection with bounding boxes. This is particularly what I wanted. Basically, I wanted to be able to find a Pokemon on a image and what position it was at. I was, in theory, going to use some additional processing afterwards to double check that the model was correct, because even my 1,000+ image trained model had some false positive, which is not great. So we're going to do object detection, and we are going to delete the airplane and car labels, and we're going to create our own labels. I used very short names just because I was being lazy. So I called them P, P2, and PZ. And I don't know what the rest of this is, so I just ignored it and clicked save. All right, we've created a project. From this, you want to import your data. In this case, we're going to be importing our raw images, and we'll then go through annotating them. To import stuff, you click on this import. There are a bunch of options for cloud storages and stuff. I could not get any of them working. There's also an option for local stored files, which would be great, which would allow me to mass import files because I had 1,000 images and could have just imported them all. Couldn't get that working either. So I just went through the manual upload flow. And the upload flow is actually sort of broken. You need to only upload, I think it's 40 files at once, otherwise it just crashes. And I found this out through trial and error. Otherwise, it just sort of breaks and does it in a mysterious way. So I don't know, we're going to select these number of images and upload those. Once it has uploaded those, you can then upload more. So we did up to maze 2. We'll do maze 3 onwards down to here. And that'll import all of our data. I chose 50 files for this. 50 is definitely not enough to build a machine learning model, but it's enough to show you this tool. Okay. The other thing that I found really annoying about this tool is it doesn't tell you any of its keyboard shortcuts, so I had to search through the bug tracker and read the source code in order to figure them out. So I'm going to tell you the ones that actually matter here. We're going to start by clicking Label All Tasks, and it's going to throw us into a bunch of images. I recommend making this as big as possible so that you can draw your boxes as accurately as possible. That does tell you one of the keyboard shortcuts here. It's a little bit subtle in what it's telling you. But if I type 2 here, this is a Porygon 2, it's going to put me into the box drawing mode for label number 2. I can draw a box around it, and then you click submit. But moving my mouse all the way over here to click submit is a lot of work. I didn't like that. And so I searched around for a keyboard shortcut. This is a Porygon, normal Porygon, so we'll press 1. And if you do Control Enter, that presses the submit button. Took me forever to find that, but once you've got that down, you get in kind of a rhythm, and it's pretty easy to annotate these. Oh, and if you mess up a box, you can click on the box and then drag the boundaries. But it's still very tedious, and this is kind of the slow, annoying step of this process, is to go through and annotate all these images. I'm of course not going to annotate all of these. I did want to get to one where it didn't have anything on it, just so I can show you that you would skip one that doesn't have anything. And it is important to have things in your data set that don't match. That way, I mean, the training step will generate images that don't have any matches, and so it'll still get it from there. But it's also useful to have other stuff that may appear in your data set, this bush is actually pretty nice that it happened to be in this data set, so that it doesn't misidentify that, or other things like that. But anyway, I'm not going to go through all of the annotation here. We'll just assume that I've done all those, and let's just say that that's good enough. Once you've annotated or labeled all of your tasks, you're then going to export them. I hope it lets me export without having done all these. And it gives you a whole bunch of export options. We are specifically using the yolov8, so we are going to pick the YOLO object detection. And oh, that went really fast. Usually this takes 10 minutes to generate the output file. I guess I only had 11 images, so it was a little bit faster than that. And so that'll give you your export here. And that should live in downloads. Yeah, so if we look at this file, just to unzip it and see what the contents of it looks like, y/, oh no, project 1. You'll see that it spit out an images directory and a labels directory, as well as some other stuff here. Notes, classes, etc. Basically tells you which object classes live where. I don't know what notes is, doesn't matter. Labels are the boxes that we drew, and images are the original images. Cool. From there, you need a GPU. I guess you could train with CPU, but it's going to take a lot longer. I don't have GPU pass-through working on my Linux machine. Oh, surprise, I'm actually on Windows, so we'll be able to open up command, and this is where we're going to do our training and validation here. You'll note here, though, that our output here just has images and labels. And typically, when you train a machine learning model, you'll split your data set into 3 parts. One being your training set, one part being your validation set, and one being your test set. And kind of the reason for separating at least the first 2 out is so that you can train your model, and the last one is so that you have some separate data after the fact that you can validate that the model works. I looked online and they recommend like a 70%, 20%, 10% split. I didn't question that, and so I just went with that. But there's not really a great way to split this labeled data into that particular set. So I wrote a little thing. You can get to my modeling directory where I did all of my work here. That's probably big enough to see. And I wrote a little thing to split my data set apart. Not really that fancy, but basically take the data that we just downloaded, split it into train, validate, and test. These are the conventional names that other people are using, so I just follow their directions. Find all of the exported images, shuffle them up randomly but deterministically. That's what this 0 is. I'm seeding with 0. And then basically splice out 70% and then 20% and then the remaining into the test set. Copy those out. And finally, you need to tell YOLO about your data set. And so it requires that you make this data.yaml. It has some stuff in it, NC number of classes. These are the names of the classes. And then it wants to know the particular directories that your training, validation, and test sets live in, and generates a YAML file from that. I have already dumped a much larger training set from before and unzipped it here. So if we look at export here, this is a larger, this is the final one that I made before giving up on this. But and if we run that split data set on it, Python dataset, it's going to go and generate that structure that we needed. Cool. The next step of this is to install Ultralytics. And I don't have Conda or anything else set up, so I was just going to do this with pip. Quick start. And they walk you through a video, but it turns out this isn't what you want. And you can validate if you've run that and gotten it in correctly. I've actually set this up already. So vm oops cpu scripts activate. This I already ran pip install Ultralytics in. You'll get a binary called YOLO, and you can run YOLO check on it. This will give you like a little system check to make sure that everything is up and working. And it'll tell you all the dependencies it installed, blah, blah, blah. I'm running on Windows 10, Python 3.10, etc., etc. But this first line is what you really want to look at. This is the important one here. You'll notice here that it talks about Torch 2.2.2 plus CPU. This is a CPU-based PyTorch. And we don't want CPU-based because it's going to take too long and be real slow and stuff. If you've set it up correctly, you should see some GPU information here. And in order to get a working GPU, I had to run this command, or a GPU version of Torch. I ran this command. Pip install Torch, Torch Vision, Torch Audio from their custom index URL. And that is actually listed on the Torch website. So props to them for getting this and having it actually work. I don't know why they put pip3. Pip3 is not really a thing on Windows, so I just got rid of the 3. I'm also using an old version of CUDA because I have an old GPU, so that's why I'm stuck in CUDA 11.8. but maybe you have 12.1 because you have a new enough GPU. All right, once you've done that, you should end up with a virtual env. Let's see if you have with GPU scripts activate, where you can run YOLO check. This should tell you, yeah, it should tell you that you have GPU set up. This is my 1080 Ti that is 6 years old now. Once you have a GPU, you could start training. Cool. So we split the data set. You can see there's this split. There's this data.yaml. Just show you what that looks like. Tabby. Oh, it's actually JSON. Fun fact about YAML, JSON, it is backwards compatible with JSON, so I was able to just generate this more easily than trying to fiddle around with YAML. But you'll see that it has our classes, their names, and the locations. And if we look in this split directory, we have 3 directories for our train, test, train, and validation. Cool. From there, you can run the training. This takes a really long time, so I'm just going to start it and then Control-C it and show you kind of what it looks like. Train.bat. This is the command that I ended up using. The one that it gave me, or the one that it recommends, did not include this batch argument at the end, or this image size. I don't really know what the right value to pick for this was, but I was using 1280p images, so I set this. Apparently this value is too large, and usually you should use like 600 or something. I don't know. This seemed to work for me. And you pointed at your dataset YAML. This batch argument here tells it how many instances to use, and I'm actually going to set this to a larger or a smaller number because my computer is recording video. And this value is basically how many parallel things it tries to do. And if you set the number too high, you get an out-of-memory error on your GPU, which is not great. I guess I could show what it does. We're not going to show what it does, but trust me, you get out of memory, and it's really hard to debug, and the error message is not great. But once you've set this up, you can start running it, and it's going to go through, in this case, it said epochs 25 up here. It's going to go through 25 rounds of training here. And it basically sets some stuff up and then whirs up all your fans and goes through each round of training. And it gets better and better over time, in theory, and after 25 rounds, it picks the best one. At least that's how I had set mine up. So that's going to take forever, and I'm not going to... Let's get to the fan whirring part. This is just it generating image caches. We'll give it a sec. Hasn't actually started training. But yeah, this is basically something that you press a button, you walk away, go get lunch, maybe go see a movie. I don't know. It takes a long time to generate this. In theory, it's faster if you have better GPUs, but I don't. So, once it's done, it will spit out some structures here. Let me show you what a previous training run looks like. Modeling previous. There, I'll show you the bad one. So you're gonna get runs, and I actually had to train twice because it crashed my GPU. And you're gonna get a bunch of output that looks like this, including the model weights. I'm far from a data scientist, so I don't actually know what this is. My guess is that this is a matrix where it should be a diagonal, and all the other stuff around this is misidentification. You can see here that I had very little annotated data, and so my model was probably not going to be very accurate. And I'm told that this confidence curve is not what it should look like if you've trained a lot of data. It should be, very high for all of these, and a bunch of other stuff like that. I don't know what any of this means, but this is presumably the intermediates and then the validation. I don't know. Anyway, it spits out a bunch of stuff like that. When you get better models, like the 4th edition of this that I did, you'll have a much better diagonal. Still some failures here, but and this curve looks a little bit better there. So I'm told. Again, I have no idea what I'm talking about, so this is all stuff that I just sort of picked up as I was doing this. Okay, cool. You can see it started training here, and this takes forever, so we're gonna cancel that. cancel that. God. Hopefully that cancels. I don't know. Anyway, once you've run that, you'll be able to run a test of this. And I have another command for that. In this one, we're going to tell it where our model lives. And then this is what someone else told me to put, so I don't know. This is basically going to take your model and use your test data set and spit out outputs of what it annotated. And we actually looked at some of those earlier when I was showing you the those images. It'll spit out this predict. It also takes a while to run, so I'm not going to do that. But you'll be able to see like kind of a sampling of how your model operates on various images here. So you can see like, oh, it didn't look at the syndical. Great, perfect. I think this particular one, yeah, there's a big old Porygon too. This one, even though this was after training thousands of images, it was pretty good on most of these images, but somewhere in here there's a false positive. No, not there. This way. So here you can see like it wasn't very confident in it, but it thought that was a Porygon Z for some reason. Don't know why. Didn't really debug the model because I ended up finding the answer somewhere else. Oh, here's another problem. Like it thinks there's a Porygon here, and then it's actually fairly confident in it, but it's actually a Luxray, which is not the Pokemon I want. But anyway, this is how I made a custom object detection model, and I was pretty surprised at how well the results worked, to be honest. I thought this was going to be a complete failure, but fairly good. And you can see like how long training took. So I spent probably about, I don't know, 5 or 6 hours annotating data, a couple of days running the GPU training. And oddly enough, by the time I got a model that I was pretty happy with, you know, this one that still had some false positives, I had actually found it using a much dumber algorithm. My dumb algorithm basically looks for find pink on the screen, find blue on the screen, and see if they intersect. And that was good enough to eventually find the shiny Pokemon I was looking for. But anyway, that is making a custom object detection model. Yeah, I learned a lot, but I don't think I'll ever do this again. So hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.